Okay, so this is yet another Silicon Dojo class. If you don't know, I'm Eli, the computer guy. I've been doing tech education since 2009. Been doing tech since 1996. Started in the army, blah, blah, a whole bunch of crap. YouTube is a disaster. It's a disaster, my personal opinion. So I'm trying to move away from YouTube because, yes, as they say, rats are the first one to get off a sinking ship. I am proudly a beta rat getting off that damn ship. And so the idea is Silicon Dojo, actually doing interactive tech education. I tried to do an in-person tech education thing here in Asheville. People in Asheville just didn't really care. So now we're trying to do this online. So you get virtual anywhere in the world and interactive. We'll see how this goes. Silicon Dojo, authorityless, gatekeeperless, free to the end user, hands-on technology education that empowers students to do whatever the hell it is that you want to do. So basically the idea here is, what if technology simply existed? Whoever wanted the education could come and you could do whatever you want to do. If you want to use VS Code, use VS Code. You want to use PyCharm, use PyCharm. Look, you ain't getting a grade, right? You take from this education whatever it is you want to take from this education. I will say, free to the end user is not actually free. I came up with this phrase, free to the end user, back in 2012 in Baltimore when I was making money off of YouTube because it was amazing, right? People were getting education that they did not have to pay for. I was getting paid. I was getting paid so much money back in the day. And advertisers, they were getting ads in front of the eyeballs that they cared about, right? So that's the idea, like free. So the student gets free education. I get paid. I still need to get paid. Advertisers are happy. Anyways, we're trying to figure out how that works in this world because sponsors don't actually want to sponsor this. That gets into its own thing on social media. So we do have a donor box account. If you would actually like to help support this, donorbox.org/ETCG. You can drop in a couple of dollars a month. That would be very useful. Because again, there are no banner ads. There are no banner ads. Anyways, let's see here. If you need to ask a question, do make sure you raise a hand in Zoom. You go to React, you raise a hand wherever the hand is up there. I always get lost. And that's how you raise a hand. You can raise a hand at any point, and when I get to a point in the class, when I'm able to, I will answer the question. Do try to make the question topical to the whatever the hell it is I'm talking about at that moment. At the end of the class, I'm more than happy to answer any question about anything. But during the class, let's not get ADHD. Focus on whatever it is we're talking about. Now, copyright all the material that I've created. So again, if you go to GitHub, all the material's there, the code is there, the slides are there, all this information is there. You are free to use it. You are free to use it and make money off of it. If you want to create your own education program in Mogadishu using my program and charging whatever the hell Mogadishuans use as money, feel free. Tippy tap or die. One of the big things in the technology world is a lot of people think they're going to watch these classes. I'm going to watch this class. You will get the information in your brain, and then you'll become like Neo or whatever on the Matrix, and you'll be an expert. That's not how technology works. If you want to actually become a technology professional, you have to do the work. Every single class we're generally going to have 3 labs. Do those 3 labs. Again, the big concepts like replication strategies and left outer joins, that we're going to learn about today, that's actually pretty simple. Remembering to always close the single quotation marks. That's what's difficult. Again, Silicon Dojo, again, I did martial arts for many, 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 many years. And your instructor can tell you to keep your hands up. Your instructor can tell you to cover the hell up. Your instructor will say again and again and again, think of a rubber band with your hand to your head and keep your hands up here. Until you get beat in the head for the 50th time, you're not going to do it. Extra help, w3schools.com is absolutely fabulous for almost everything we're going to be teaching in these classes. And of course, ChatGPT. ChatGPT is not artificial intelligence, but it is still very useful, especially for code. Standardization, we talked about PyCharm. We use VS Code and the default settings. We use that, so if we go through troubleshooting, it's very easy for me to just help you, support you with what you're doing. If you use PyCharm, fine. I don't actually use PyCharm. So if we pull up your screen, I'm not necessarily going to know what I'm looking at, right? That's one of the importance of standardization, one way or the other. Material, again, eli@computerguy.com. So all these classes are getting recorded. And I'm trying to make it better. I'm trying to figure out how to do this in 4K. Haven't figured it out yet. So anyways, if you go to the Eli, the Computer Guy channel, you will see all of our classes are up here. Where's Bottle? Crap. Did I forget to upload Bottle? Uh-oh. Anyways, most of our classes, they're up here on Eli, the Computer Guy channel. So you want to watch them afterwards. And the material is if you go to github.com/Silicon Dojo/online hyphen classes. We have all of this material for all of these different classes. Again, what I would tell you to do, where the hell are we today? SQL Introduction, right? It'll tell you where the video is, a whole bunch of other stuff. But we have a lab book. So the lab book is basically the labs for you to do. And we also have the workbook, which is basically for notes. So this is all the slides, 3 to a page, blah, 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 for you to scribble down notes. Again, everybody that gets into technology, they think, I don't need to write notes, I will remember it. And you are all wrong. And then finally, trolls, everybody is muted unless I allow you to unmute yourself. And if I see stupidity going on in the chat, I will simply disable the chat. And that is how we deal with trolls. And with that, I really need to get that to be a shorter spiel. But other than that, we're going to get into SQLite today. So SQLite! Woo! Again, a lot of people think I do not get excited about technology. But again, to be clear, I am not passionate about technology. I'm passionate about travel. I'm passionate about art. I'm passionate about my dog. That sounds a little weird. Passionate about my wife. I'm not passionate about technology. But I do think it's exciting and interesting. But a lot of people think that I'm over the hill and I'm crotchety because I don't give a damn about quote unquote AI and I don't give a damn about blockchain. And the reason is somebody who actually uses this stuff and is not a bold-faced liar. I find SQLite to be a zillion times more fascinating than blockchain, right? And so that's one of the weird things. Again, you get in the technology world, one of the things that can run you into problems is when you're not excited about what all the other cool kids are excited about. But anyways, right? One of the things you need to be thinking about when you think about SQLite or when you think about blockchain or anything else is basically what problem are you trying to solve for? Again, whenever anybody says, oh, AI is amazing or blockchain is amazing, my first question is amazing for what? Amazing for what? Again, blockchain. Think about this with blockchain, right? We're all supposed to be excited about blockchain. Blockchain is the database type of the future, except nobody uses it other than the crypto bros, right? And think about it. It's a highly distributed database type system, immutable. Once you make a change to it, you can't modify anything else. That constantly grows over time. That is also pretty damn slow. And you really start thinking about it. Crap, what is the use case for this thing? Right? Well, the interesting thing with SQLite, what the use case for SQLite actually is basically you get all the power of what's called a relational database system with the administrative overhead of a text file, which is wonderful. And SQLite runs on damn near anything, including a moldy old potato, right? SQLite is actually the most installed database engine in the entire world. It's more or less installed on every single mobile device out there, any mobile phone, anything like that, iOS device or Android device, plus a whole bunch of other things, because it is so simple and it is so fast. And apparently you can scale this thing to an incredibly large size, something like 240 terabytes. You can make the database of SQLite. And the nice part about it is again, the administrative overhead is more or less, I mean, not much. Again, you get to 240 terabytes of a database. I don't want to be administrating that piece of crap. But anyways, right, keep it pretty small, right? So we use MySQL. So I love MySQL. MySQL database engine is one of the things a lot of people use. Again, like with Postgres. Postgres is another database engine a lot of people use. And one of the things to be thinking about with that is it's a very, very good, very powerful database server, but it has a whole bunch of administrative functionality built into it. So I actually went through a 40-hour MySQL administrator course. I don't know, 15, 17 years ago at this point, back when MySQL was actually still owned by MySQL. And the reality is administering a MySQL database server, if you're going to be doing anything that's going to be significant, is a big deal, right? You've got privileges. So in the database server itself, right? Not in the operating system, in the database server itself, you have user accounts with privileges, basically security policies. Beyond that, you can do replication strategies, so replicating data to other databases, so you can have a cluster of database servers that are all providing services. You have read databases, you have write databases, you have master databases. They still do that kind of thing. You do mesh strategies. Oh my God, right? MySQL is cool. MySQL is awesome. But it requires a little bit of training just to get a MySQL database server up and running. The cool part with SQLite is basically as we'll run it, there is none of that. There are, again, this is dangerous too. There are no user accounts. There are no, clustering strategies. There is no security whatsoever. You can actually open a database file in a text editor if you really want to and be able to scrape some of the information. Basically, you can copy and paste the entire database, which is both awesome and horrifying at the exact same time. So if you have a database file, just like if you have a text file, right? So if you have a database file with MySQL, Postgres, or whatever else, if you have encryption or anything else like that going on, you can't necessarily move it simply from one server to another. Simply can't copy and paste it. One of the cool things with SQLite is you can take that database file and you can copy and you can paste it. You can put it on your flash drive and move it all around wherever the hell you're going to. You can replicate out the entire database file, right? Lots and lots and lots of really cool things. And that's why I get excited about SQLite and why it's going to be useful for us. Again, what problems are we trying to solve in these classes? One of the big issues is we need to be able to create projects that's going to store data, right? You're going to store sensor values, going to store responses from APIs or from OS commands or that kind of thing, right? We need some place to be able to store that data and to be able to recover that data or be able to read that data relatively easily. You can do that in a text file, but then you're using what's called CSV, comma separated value files. That can be a bit of a disaster. So wouldn't it be nice if we can get all this stuff in and then we can simply dump it into what's called a relational database to be able to do searches and queries and inserts and updates and all of that kind of stuff, right? That's the problem that we're going to be solving here. What is a relational database? So you're going to hear a lot about relational databases. Again, in the modern world, we have generally we have relational databases and NoSQL databases. Not dealing with NoSQL today. Relational database, was the big, cool, sexy thing 20 years ago. With a relational database is basically goes by the ACID standard. You'll hear the ACID standard and the base standard. We're going to deal with the ACID standard with the relational databases. How do you say these words? Atomicity, atomicity. Why did I become an instructor? Anyways, atomic. It has to be atomic. It has to be atomic. It has to be consistent. It has to be isolated and it has to be durable. So what does atomic mean? All commands are a single unit. They either succeed or they fail together as an entire set of commands. So remember, we're dealing with a database that's going to be storing data. All it does is store data. So one of the things you don't want to have happen is while you're doing a SQL statement. So a structured query language statement is the language we're going to use to communicate with the database server. What happens if we put in a statement where we're doing something and some of it works and some of it fails? But you're dealing with this on the data store. Do you want some of your command to work and some of your command to fail on 1 million records? Probably not. That would be a bad thing. So what it means by atomic is when you run the command, either the command works in its entirety or it fails in its entirety. It won't do half the damn command. right? That's the kind of stuff you have to think about as a tech professional. Consistency. Changes are implemented across the system. So when you have the database server, basically when you make the addition to the database server, or you delete or you update or whatever else, that it's consistent across the system. So whatever user is accessing the data at that point in time, all the users will get the exact same data. Isolation. Each transaction is isolated from other transactions. So basically, every transaction goes into the SQLite database server, one after the other, after the other, after the other, after the other. They are isolated, so you don't send like 5 commands, one fails, then everything else fails. They're all on their own. And durability. Once a change is created, it persists. Again, that's one of the things with relational database servers is, again, to think about if you're doing an accounting system, think about if you're doing an inventory control system, think about anything. When you put the data in, you want to know that it's going to stay there. Right? And so basically that's the idea with an ACID system, right? Again, there's something called a base system we are not going to go into today. Those are faster, a hell of a lot easier to scale, become much larger, the whole 9 yards, but they don't necessarily do this. Again, that's something to be very, very, very careful about. When you're dealing with a relational database system, you have something called a schema, which means you have to plan. You do have to plan. Again, do remember as a technology professional, most of your job is sitting at a whiteboard like this. 10% of your job is tippy-tappy typing code and actually making something work. Most of your job is sitting at a whiteboard figuring out what the hell it is that you should write. And so basically what we're talking about with the schema, right? So you have a database, and then in the database you have tables. And so these tables have names, right? You know, people, places, whatever else. And each one of these things, so we have a people, let's say we have the people table. And so we have the schema for that people table. We have an ID for the person, right? That's a column. We have a first name for the person. That's a column. We have a last name for the person. That's a column. We have an email for the person. That's a column. We have a phone number for the person. That's a column. So on and so forth. And so these are the columns: ID, first name, last name, email, phone, anything else. And then going down, you have the records, right? ID 1, Eli, blah, blah, blah. ID 2, Lewis, blah, 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 blah. ID 3, all these different people, right? And so anyways, this is what we're talking about with a schema. So when we're using Python code to read and write to this database, we have to know what this schema looks like so that we know what the hell we're writing to. Insert into the people table, value for first name, last name, email, and telephone number, or first name, last name, email, telephone number, or values, Eli, blah, 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 blah. So we actually have to know what that schema is. And so that's a big thing with these relational databases. When we talk about NoSQL databases, those are schema-less, which a lot of the kids, they like that. Oh, you mean I don't have to plan? I can just build crap and not deal with whiteboards? Isn't that better? Yeah. Telling a 22-year-old to build infrastructure and not plan it before they build it, that's just such a wonderful idea. But anyways, basically what schemaless databases are is where they don't have this. And actually programmatically, you just dump in values, a lot like JSON, sort of. And then, again, if you want a new, essentially column name, sort of, in NoSQL, you just add it in the code, right? But anyways, with a relational database, you have to actually do this schema. And so the big thing with the schema is, again, especially depending on the software that you're using, you can what's called alter the schema for a table. So basically change it in some way. You can add or subtract things, but that gets to be a little bit dangerous. It's like, yes, you can do that on an active in production server. I would rather design it properly in the first place. And then we get to joins. The big thing with relational databases, again, we've got these different tables here. And so basically what the join does, it is allows us to join the tables based off of certain values in the columns. So let's say we have a parts database, right? So we have the parts table. Right. And so in the parts table, again, whenever we're building stuff in technology, we want to make every single unit we're dealing with as small and as easy to understand as possible. Right. So if I'm dealing with a parts database, right, there's probably certain information about in this parts database I care about, right? An ID number for the parts part, right? A name for the part, obviously, maybe a price for the part, and then maybe we want the information for the manufacturer, right? So a part is going to be created by a manufacturer. But do I want that manufacturer information in the parts table? Right? That kind of makes the parts table get really big. So what I can do is I can have a manufacturer ID, right? And then over here, I can have a table for manufacturers. And then I can have an ID here, and the manufacturer then, would have name, it would have address, it would have your, whatever your billing number is, or what your parts number is. It would have a whole bunch of information, right? And so instead of having this manufacturer information all through this parts table, what we can do is called a join. And so what a join does, right, you can do a join, is when you do a SQL statement, a structured query language statement. Basically, you say, we're going to join on parts, manufacturer ID, and manufacturer ID, and then we're going to make this basically one long response for our query statement. So instead of just having us all in the parts table, and that's where you get into a true disaster when you start building these damn things out, because that's where you can have, 100 different tables, right? So again, you have the manufacturer, and then maybe with the manufacturer, you have point of contacts in here. And then the point of contacts, you then have another table that has point of contact information. And that point of contact information, you might want to have another table as information about those point of contacts. And this is where, again, you need a whiteboard to design all this out, because trying to figure that out can be a mess. Again, do remember with technology, you don't have to be smart to be a technology professional. You do have to be precise. Nothing I am explaining here is really that complicated once you give it a few minutes to set in. It is tedious as hell, though. It is tedious as hell. We talk about relational database systems, RDBMSs, again, as they're called. You'll have heard of MySQL. You'll hear of MariaDB. MariaDB is a fork of MySQL. Postgres is currently what all the cool kids are using. MySQL is Microsoft's version, because they always got to have their own version. And of course, SQLite. Again, a lot of kids like that right now like to use Postgres. It is what it is. It's either MySQL or Postgres. One is faster with inserts and one is faster with selects. Which is which, I don't know. And at what scale it matters, also, who the hell knows. Again, that's going to be one of the things to be thinking about when you're building out your infrastructure, because you're going to get some people out there, they're like, oh, this one's so much faster. And you're like, for the 10 users an hour my system is getting, I don't care. Right? That's going to be one of the things to consider with whatever you're doing. Or again, if you're trying to get a job, again, I know here in Asheville, whenever I talk to anybody about database systems, they're always talking about Postgres. So if you're trying to get a job here in Asheville, you would learn Postgres. Yes, Jock Stroud. Oops, fuck. Admit him. What's up, Jock?
Hi, how's it going? I stepped away for a quick second, so I don't know if you cover this. For the schema, because you are working with you might be working with legacy systems or whatever, is there any way to find out what the schema looks like as you're working with it, like what the order is? So in the example you had ID, name, address, so forth, so on. Is there any way to find out if that might be the order, or you just have to kind of guess? Is there any way to kind of look it up on the terminal or anything like that?
We do. I will show you that. You never guess. The
Oh,
real
okay.
answer to this question is you never guess. You figure it the fuck out. Yeah, no. But I will show you that in a second. Yep.
Thank you.
Yep. Okay. Yes. Again, there's the question that you all ask, and then the question I'm going to answer. And the question that I'm answering is you never fucking guess. You always you was it you ver as I always say, was it? Oh, anyways, verify, and when you feel really confident, verify one more time, and then ask a buddy to check your work to make sure that they agree with it. But no, you always make sure you know what you're doing, especially when you're dealing with the database system, because you well, so this is where all your data is going. This is the most important thing in your entire platform. If you screw this up, oh, so bad. It'll just be so bad. So anyways, so we have all these different systems. The important thing to think about with this, though, is SQL. So structured query language is a specific language. When I talk about selects, when I talk about inserts, I talk about updates, I talk about that type of thing, right? Select star from table, whether you're using SQLite or whether you're using Postgres or whether you're using MariaDB or MySQL, that is always going to be the same. That is a structured query language. Where it gets a little bit more complicated, though, is then there are going to be commands that you're going to use in order to administer the database server. So again, with MySQL, so you do like show tables or describe tables. So if you're trying to look at like the schema of a table in MySQL, you would use DESC space whatever the table name is, and that should tell you what the hell the table is supposed to look like. Right? But that's for MySQL. In SQLite, they use a different command. It's period. So everything in SQLite, in order to run a command, is actually a period. And so it's period schema space, whatever the table name is. And that's what will basically show you the schema of that particular table. And so where you'll get into trouble, and again, this is the big problem in the technology world, is you know exactly what you want to do. You may have done it 1,000 times in the past, but now you're given this thing, and all of a sudden you're trying to figure out why your commands aren't doing what the hell you think they should be doing. And again, that's why I talk about standardization. Standardization. Very rarely will I hammer on you on actually using a specific product, but I will tell you in your organization, standardize on whatever the hell it is that you're going to use. Especially when something goes boom, you want to be able to troubleshoot it relatively quickly. Installing SQLite 3. So it's SQLite version is currently 3. It should be installed on any system that already has Python 3 installed. We talked about this a little bit earlier. If you have Python 3 installed, if you've been doing any of these classes up until this point, it should work. It should work. Hopefully. You can go to SQLite.org page, you can basically take a look at it. They have a bunch of information there. Also for the Python module, so again, whenever you're interacting with anything in Python, you're almost always going to have to import a module. The SQLite 3 module should be installed in your Python environment by default, so you should simply be able to import it and go away with it. So you should not have to install SQLite on your server or on your computer, and you should not have to install the module. If you do, have fun troubleshooting. Yay, troubleshooting. Okay. SQLite 3 commands. So these are the commands for SQLite 3 itself. So in order to run SQLite 3, you just simply do SQLite 3. So SQLite 3 and then space and whatever the database name it is that you're connecting to. So an important thing to understand is if you simply run the command SQLite 3, so let's go over here. Okay. .exit will get me out. Right? Clear. So I can do SQLite 3, right? And I do that. Yay! Right? This is exciting. You got SQLite running. I can guarantee a couple of you are going to do this. And then you're going to be crying in about an hour. Because you're going to go and you're going to do a lot of work. And then you're going to exit and all that work is going to be gone. Something to be very careful about, if you simply run SQLite 3, not connecting to any database at all, basically this opens up a temporary database. So you can create tables. You can create 1,000 tables. You can populate 1,000 tables. You can do all kinds of fancy stuff. As soon as you exit, it all goes bye-bye. So be careful about that. So if you simply do SQLite 3, it will open up. You will get the shell, but that it'll go away. It's all temporary. Again, which might be useful for you. Again, one of the things to be thinking about from a cybersecurity standpoint is any data that you save is data that could be compromised, right? So if you create a database file for whatever it is that you're doing, right? You're scanning email addresses or whatever else, right? You're using OpenAI to parse files, to pull out email addresses, and then once you have those email addresses, you're going to feed them to something else. Something to think about is if you actually create a database file and then you use it for whatever the project is, and then it just sits there, right? It just sits on your server because that's what happens. Nobody ever cleans up their servers properly. It just sits there. Remember, as long as that file sits there, it can be compromised by somebody. And whatever information is in that database file then could be used for nefarious purposes or whatever else. So one of the things to think about is if you simply need like a database, again, for a temporary processing procedure, right? You're going to go through, you're going to scan the email addresses, you're going to associate them with names, you're going to send out some kind of message. You may all want to do that in a temporary database file so it all runs. You send out the commands, you do whatever it is that you want to do, and then when you close, that database file goes away so that it cannot be compromised in the future. Again, that's the kind of thing you need to be thinking about when we talk about stuff like architecture, how you're actually designing the systems. So anyways, in order to actually connect to a database that I've created, SQLite 3 space, and then I created this database called class.db. So we come in, and we just get the class.db. So with this, so I'm in my root directory where I have this. If I have not created this database yet, it will create this. So it will either connect to the database or it will create the database. Also, something to be careful about, because if you already have a populated database, and then you use a script to connect to a database but doesn't exist, so it creates the database, then you might run into your own problems. So just realize this either connects or creates the database. From here, again, when we talk about the commands we can use, tables. There we go. So I could do dot tables, and this will show me the two tables I have. So I have a student table and I have an allergy table. So that shows me the tables. Again, in MySQL, it'll be show tables, and here is dot tables. If I want to see the schema, so let's say I want to see the schema of student, basically how it was created, do dot schema and do student. And so the command that was used in order to create this table was create table student, so the student name with a column of name, column of age, and a column of allergy. So I know what that is, right? If I want to see the schema for allergy, I can do dot schema allergy, and the same thing. Create table allergy, and so name of the allergy and the rule. Right? And so that is how I can see what this table looks like. Now, if you're used to other database systems, you're probably looking at this and going, what the hell? I'm an Eli. That looks like crap. Again, you remember, all the power of relational database system with the administrative overhead of a text file. So normally, when you're dealing with databases, you're going to be dealing with data types. Right, so the data type, so you do name, and it'll be text, right? We talked about data types before. You have strings or text, you have ints, you have floats, you have bools, all kinds of different data types. So normally, you would actually associate the column name with the data type here to make sure that you don't run into a problem in the future, that you don't put Bob into age. One of the issues with SQLite, which is interesting. Again, it's the mentality of how people design products. SQLite, and if you read this, you got to read it like 5 times. And like, oh, they're not lying. Okay, so SQLite associates the data type with the actual data itself. So if you have Bob, it considers that a text data type. If you have 12, it considers that an int data type. So it thinks that it data types the actual specific piece of data, not the column of data. So when I do this, this probably looks really bad to you. But the interesting part is I could do name, text, age, int, allergy, text. And if that's all I do when I create the table, basically I can still put Bob in as age. If you define the data type when you're creating the table, and all you do is define the data type, SQLite just takes that as a suggestion. It's like, oh, that's a nice suggestion. And then it's not going to use it, right? You can still. So you actually have to put a strict at the end. If you don't put strict at the end, data types are not paid attention to. So, good part about this is it's really easy to create a database, create tables, and dump information in really, really, really quickly. Bad part about this is you don't necessarily have data types. That can get bad quickly. Let's see here. Other things we can do. So we can do, let's see, if I do select all from student. So this is our first SQLite structured query language statement. Select all columns from the student table, and then we do a semicolon. So one of the things you're going to notice here is when we do commands to SQLite, there's no semicolon. It's dot schema, dot tables, dot whatever else. No semicolon. When you do structured query language, the delimiter, what ends the command, is that semicolon. So anyways, we're going to do this. And so we're going to see I have Bob, who's 12 and has a peanut allergy. Bobby, who's 15, has a dog allergy. Frank, who's 14, has a sun allergy. Nancy, 14, has a cat allergy. Tommy's 15. Jenny's 11. Trish is 16. One of the things we can do is, if we take a look at this, we're like, that's not really that easy to understand. One of the things I can do is we do headers on. So again, notice no semicolon. Hit that. Then we run the command again. Again, if you just press up, it'll run the command again. And so with this, with headers on, we get name, age, and allergy. So we can see, okay, name is there, age is there, allergy is there. We don't get the data type or anything like that, but at least it starts to be a little bit better. But then you look at it, you're like, that's not really great. So I think it's blah, 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 mode column. Yep. So one of the things we can do is we can do dot mode column. We can run the exact same command again, and now we get something that's a little easier to look like. Name, tab spaced, age, tab spaced, allergy. And so again, this is going to be the type of thing that you need to be thinking about when you're interacting with a system. Do you care how pretty the output is or not? Sometimes it'll matter to you, sometimes it won't. So again, you can do dot headers on, that will give you the headers. You can do dot mode column, that will give you the column. These are commands within the SQLite. They're not the actual SQL statements themselves. Let's see here. So yeah, we have got that. Delimiter, again, as I said, when we're actually using structured query language, the delimiter is always going to be that semicolon. That is what ends the statement, right? So I can do select, enter, and this is where people also get confused. See how there's that little arrow there? So I can do select all from student. There we go. So basically, when you hit enter, hitting enter doesn't do anything. All right, this is where people get really, really, really confused. Is they're like, crap, because they'll screw it up. And they're like, okay, I just wanna kill that. But then, they forget to put the semicolon, and so they just keep, they keep saying something. Oh crap, how do I end this? You end it by using a semicolon, and then you get your nice little error. Or it processes through. That's going to be one of the things. If you take a look at this, you're going to see for a lot of people when you go out, and again, you're looking at W3 schools, you're doing research for how to do the SQL statements properly, you'll see a lot where it's basically formatted something like this, especially with creating tables. So if you want to create a table, a lot of times they'll do it this way in the description to make it easier, right? Create table students, open the parentheses, and then it'll be student ID, auto increment primary key, comma, name, text, comma, age, int, comma, allergy, text, comma, and then they'll close it and do the semicolon. So you'll see that in a lot of descriptions. And basically, the reason that they're able to do that is because until you hit that semicolon and hit enter, it's not actually going to process through. So one of the things to be thinking about when you're doing SQL statements is you don't have to do multi-line SQL statements. Like if you know what you're writing, you can just write it out all in one line and then click the semicolon and hit enter, and it'll all fire off. The other thing that's useful too is if you do it all in one line and you make a mistake, is you'll notice here, if I do up, it will only do like the last line. So see, you select all from student. So what if I made a mistake there, right? What if, I do that, no such table student. I can just do up again, and then I can do student, and then I can run it, right? If I do that multi-line thing, it will only give me individual lines. So I have to do select, all, right? Anyways, you kind of get the point there. So that's one reason why you might want to put everything in your SQL statement on one line. So if you screw up, or if you want to repeat it, especially when you're doing inserts, let's say you want to add 10 or 20 records into your database, it's a lot easier to put that all onto one single line and then simply repeat it as necessary. Let's see here. Okay, so creating a database, we've already talked about this. So if you simply run a SQLite 3, it'll create a temporary database. When you are done, when you hit .exit, that's how you get out. Database goes away. There is a way to save that database as a file. Do a Google search on it. I forget the exact command. If you really want to do it properly, though, you do SQLite 3, and then whatever the database name is, it'll either connect to the database or it creates a new one for you. Let's see here. Again, create tables. Primary key. So one of the interesting things whenever you're dealing with database systems is something called a primary key. So in the database world, when you have these records, every single record has to be absolutely unique, right? Right, in some way. So what if you have two records that are identical? Bob 12 peanut, but you have that two times. Somehow you got that two times into the system, right? If they're actually the same, that'll be a disaster for your database system because it won't know what record to pull from. It won't know what record to read. So every record does have to be unique. And so that's where you generally have something called a primary key. So again, in the MySQL world, you do, ID, int, primary key, auto increment, and it'll give you that nice little primary key. One of the cool things in SQLite is it actually creates automatically for you a row ID. So when you do select all, it doesn't give you the row ID. So let me just show you this for a second. Okay, so I do select, let's say all from student. All right, so I do select all from student. This is what you get. So I created a name column, I created an age column, and I created an allergy column. You will notice that there's no specific ID column here. One of the cool things with SQLite is it actually just auto creates a row ID for you. So I can do select row ID, name, age, allergy. It's a bit of pain. From student. And what you'll see is so these row IDs are already associated with these particular records, right? And so one of the nice things with SQLite is you do not necessarily have to create that primary key like you normally would. You probably do want to create a primary key because that's something that you can deal with more. Again, that goes into database management. We're not going to get into that a lot today. What I want to show you here is that one of the reasons in these examples I'm not creating a primary key is because this row ID is already created for you, so you do not necessarily need that primary key. And again, when you're just doing very basic database type system things, you may not need that. Oh, Jack, what's up?
This might be a database management question, but most data that you might input would come from an Excel spreadsheet, a Google Drive spreadsheet. So they already have, is it kind of like what you say with the, when you put it in other codes that the first section is zero? Do you have to consider that as well in this when you import an Excel spreadsheet and you create a row and a column already that the first line is always one, so you have to make your line when and you consider that when you're reading data that the first line is always one. I don't know if I'm saying this question right, but when you create tables using Excel, do you have to take anything else into consideration?
So when you create tables in Excel, if you're going to import them into SQLite, you would export them from Excel as something called a CSV file, and then generally you'd write your Python script to import the data as you see fit. So that's getting into, yeah, its own fun. We'll be doing classes and other stuff on that kind of thing. But yeah, so that's
Uh,
basically that process is the process of doing import. It doesn't really have a lot to do with Excel itself, other than Excel will give you an idea of what data you're importing and where you should dump it to.
but you don't really have to consider the numbers like you had Bob at one and two and you had name and everything like that. But in an Excel spreadsheet, the name and row ID would be number one, and number two would be Bob, number three would be Bobby, number four would be Frank. Kind of see the question I'm asking?
Yeah, it depends on
Like,
whether you want to import that. So you could import the row ID from the CSV along with name, age, and allergy. Or if you don't care, then you just have SQLite create the auto increment for you.
oh, it's automatic on SQLite. Automatically, it does that,
Yeah,
or
so
you
the
have to
row
make it
ID,
that
that's
way.
what I was saying. This row ID here, I did not create this. It's automatically created on every single table. Whenever you create the table, whatever else you put in there, it'll create a row ID for you.
Thank you.
Yep. Cool, cool, cool. Yep. Yeah, so this row ID, so name, age, and allergy, that's what I created when I created the schema. Row ID is automatically created. Again, whether or not you want to simply use the row ID, that is your business, but that's how it's done. Then we come down and we have the create table. So basically when you're creating the table, there's three essentially different ways to do it. So the SQL statement is simply create table, then whatever the table name is, and then what are the columns going to be? And so this is the most basic way you can do it in SQLite, right? Create table student. I want a column for name, a column for age, a column for size, and to be clear, row ID is automatically created for you. I am not assigning any data type here, and so I can plug Bob into age, and it's going to work out. I can also assign data types. Create table student, name text, age int, size text. But the thing to understand here is this is more for you. When you type in .schema and take a look at what's going on, it will tell you what type of data is supposed to be in there. But it doesn't actually fail out if you try to put Bob into the age. In order to have it fail out, you put this strict here. So create table, name, text, age, int, size, text, strict, and then that will strictly enforce these data types that you've put here. So we go over, let me just try to do, okay, SQLite. So what we can do is we can do create table, student two, right? Name, text, age, int, and allergy, right? So creating student two, name, text, age, int, allergy, text. So these are the data types that are supposed to go in there. I hit enter, it just goes through. I can do schema for student two. And if I take a look at it, create table student two, it tells me it's supposed to be text, it tells me it's supposed to be an int, and it tells me it's supposed to be an allergy. But here's the fun part, right? I can do insert into student two, and I'll do name, age, allergy. We'll talk about this in a second. And then values. So the values are going in. I'm going to do Bob, comma, Bob, comma, Bob, comma, and close. So basically what I'm doing is I'm inserting into, oops, and don't want to make that mistake. I'm going to insert into student2 table, insert into the student2 table, name, age, and allergy, values, Bob, Bob, and Bob. So we're going to try to put Bob into age. We're going to hit enter. Oops. The frick? Did I make a mistake? Oh yeah, I made a mistake. Ah. Oh, how do I get out of this one? Boop. Boop. There you go. Got it. Anyways, it's always fun doing live classes. So Bob, boop. Okay. So Bob is going to go in. We're going to hit enter. And we're going to see it went in, right? If I do select all from student 2, we're going to now see name is Bob, age is Bob, allergy is Bob. Depending on what you're using this database for, that could either be slightly funny or a horror show. So what you would do to make sure that doesn't happen, see if I get over here so you can see it. So we do create table, student 3, name, age, allergy. Oops, name, age, allergy, name, text, age, int, allergy, text, and then we do strict. So we say what we want to do is we want to strictly enforce these data types. Hit enter. Thank God that worked. Then what I'm simply going to do is I'm simply going to go back. So insert into, so just so you can see it's the exact same statement. I'm just changing the table it goes into. So insert into student 3, name, age, allergy, Bob, Bob, and Bob. And hopefully it fails. There we go. Runtime error, cannot store text value in int column. So that is one of the things that you can do in order to try to prevent the wrong data type going into the wrong column when you're dealing with a SQLite database table. But if you actually care about data types, that is also the point that you might be thinking, maybe I should go to MySQL or Postgres. Jack, what's up?
Um, I'm not sure if this is a dumb question, but so say for instance you did student two and you collected a lot of data. You don't necessarily have to create a whole new data table just to stop Bob from being put in. You can go back to student two and just make that correction in the code and it'll self-adjust, correct?
What do you mean it'll self-adjust?
So you said so in student two you didn't put in that Bob for age had to be, an int. You just put it the way it is. And people put it in, correctly, except maybe 12 times people put Bob, 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 Bob. You can go in, change student two so that now it does take it in and so it would self-correct after that. Kind of see the question, man. You don't have to make a whole new student three to get a new data type.
Oh, no. Oh. If you don't define the data type, you can put Bob or you can put 12. You can put anything in there. If you want to start enforcing the data type in the future,
Yes.
that is called hell. That is called hell.
Uh,
Don't do it. That is where we use the whiteboard. That is why we spend 90% of our time on the whiteboard, so we don't run into that problem in the future. That is what we call a fucking disaster in the tech world. So just could it be done theoretically? Don't ever do it.
Copy.
Design first. Yeah.
Gotcha. Thanks.
Yeah. Yeah, that's where we talk about you can alter a table. I'm not actually sure if you can alter a table into strict. Probably can. I mean, it's not a smart idea, but there are stupid things that they allow you to do. But the issue there is because once that column is now strictly as a specific data type, any data that's not that data type is going to cause problems. How that would fail out, I'm not exactly sure. Most likely, what you would do in that situation is you would create a new table. You would copy all of the data from the old table to the new table with the new table rules, and within your Python script, you would write a try except on what the hell to do if it fails, and then that's its own disaster. Don't do that. Whiteboard. Whiteboards are your friend. If you use your whiteboard properly, you get to sleep at night. Okay, so that's basically how you create a table. Again, one of the things to be thinking about here is with primary keys. Primary keys, again, you can create a primary key. Again, you just do a Google search for it. ID, int, primary key, auto increment, same way you would do with most SQL. Again, whether that's important for you, that's its own little world. Let's see here. Then insert data. So basically what I was just showing you, when you're going to insert data, you use the command insert. So insert into whatever the table name is. You're going to say what columns you're inserting, right? So age or name and age, right? So insert into this table. So this is going to be a new record, name and age. Then you're going to say values, and then value 1 and value 2. Again, all of this stuff, as you will see, is dirt simple. Again, in the technology world, everything is simple. You have lots and lots and lots of very simple things that all stack together for insane complexity, right? So then I look at this, let's see again, tables. So I'm gonna always make sure you know what you're doing. So I do tables, and so I can see allergy, student, student 2, and student 3. I just want to deal with student. Not sure what the command is to clear. Clear, does that work? Nope, that does not work. Okay, anyway, so insert into student, right? And then what we do is name, age, allergy, right? So basically the columns that we want to insert into is name, age, and allergy. Then we do values. So what values are going to go in there? So we do Timmy. So you notice with this, I either have to use single quotation marks or double quotation marks for strings. So text, strings, single, double quotation marks. Then you do comma, so that's the name. Then we have an age. The age is a number. So I can put in 17. I don't need, right? Because it's a number. We do comma, then we get allergy, and I'll do peanut again. And then we'll close with a semicolon. So simply insert into student, name, age, allergy, values, Timmy, 17, and peanut. And then we hit enter. That's it. Really complicated. Again, if we do select all from student, semicolon, we can now see we have Timmy, 17, peanut. Right? Not a lot to that. Admit. Man, people are showing up late. It is 3:04. If Liddell's like, yeah, I came in like an hour and 5 minutes late. Can you tell me what I missed? The answer will be no. Started at 2 o'clock. Anyways, so that's all there is into insert. Then we do select, right? So when doing a select, again, very simple. Select statements and where we're reading data from the database. So select all from table. So what this means is select all columns from the table, right? So if we go here, again, what I did here, select all from student. So we have the name column, the age column, and the allergy column. And again, row ID exists over here, but unless you specifically call it, it's not going to pop up, right? So select all from student is going to give you all this. One of the issues that you run into, again, when you're dealing with database tables, is you may have like 50 pieces of information here, right? You might have the name and the age and the allergy and the parent's name and the address and the email address and the phone number and the emergency contacts. You might have lots and lots of crap. You don't want all of that. So one of the things you can do is select which columns you want from the table. So I want to select, column 1, column 3 from the table. And that is where I can do select, let's say, name, comma, age from student, semicolon. Select the name column and the age column from the student. And now all I'm going to get is the name and the age. And so again, that can be really, really, really useful because, yeah, again, as you start dealing with data, you're going to see what a disaster it can be. And then you can also do order by. So this is cool. So I just do up. So I say I want to select name and age from student, and then I can do order by age. Right, so here again, Bob is 12, Bobby's 15, Frank's 14, right? Whatever, you get the point. We do this now, and we can see it starts at Jenny is 11, Bob is 12, Frank is 14, Nancy's 14, Bobby's 15, Tommy's 15, Chris is 16, Timmy is 17. We do the same thing. We add, I think it's DSC at the end. Is it DSC? DESC. So descending, so it should be high to low. And so now Timmy is at top, 17, 16, 15, so on and so forth, right? So basically, if you need to sort the results based off of whatever, this is alphabetical. So we could do this by allergy or by name, right? And so we can see Bob, Bobby, Frank, Jenny, right? You get the point. That's just how you order by. Pretty simple there. The big thing with order by is two words, order space by, and then what the column is. Okay, let's see here. And then we have the where filter. So basically, this is where we start doing searches, right? Again, that's where databases become very, very powerful. It isn't simply that it stores all this information, but then we can access the specific information that we care about. So again, select all from table, and we can say where a particular column is like, and then we do percentage, whatever the value is, percentage, and close. So what this does is this is using a wildcard. So a wildcard is anything before or anything after we're basically doing a search here, right? Where column like blah. So we can say, all right, so we got Bob and Bobby and Frank and Jenny and Tommy and Trish, right? So I can say select all from student where name like space, and I do the single quotation mark. I do percentage sign. That's my wild card. So anything before, I'll just do T and anything after. So basically, what I want here is I want any name that has a T in it. Of course, I have to do a semicolon. So when I do that, we now see that we get Tommy, Trish, and Timmy, and these are the ages and the allergies, right? So if we're looking for a specific thing, and that's where we start, again, we start using something like Bottle. So a Bottle is that web app framework that we showed you at the last class. So we have Bottle, that's doing the web app. We have SQLite is the back end, and that's where you can type like a search query into a Bottle HTML form. It will then send that query back to SQLite. It will pull the results back, and you'll get the research results. So we could do, again, any kind of conditional. So when you're doing wheres, where column is greater than a value, where column, is equal to a value, equal. Or no, is it equal? No, it's equal. I'm sorry. That's where you get wrong with syntaxes. Anyways, in SQL, it's actually equal. Or where column is greater than a value and column is like a value. So you can actually add things on with ands or ors. Right? So, let's see here. So we could do select all from student where age is greater than, let's say greater than 15. Okay, so Trish is greater than 15 and Timmy is greater than 15, so 16 and 17. What we could do here is we could say where age is greater than, let's say, 13 and age is less than 17. And so where is greater than 13 and less than 17? Bobby is 15, Frank is 14, Nancy is 14, Tommy is 15, and Trish is 16. If we just wanted to try to get Bobby out of this, right? So we could say, oh, and where is this? And name like B. Again, this stuff can get as complicated and stupid as you want to. So select all from student where the age is above 13 and the name like, so basically has a B in it with those wildcards. And so we get Bobby is 15. So again, if we're like, oh, that kid, their name has a B in it, and they're older than 14 years old. You can basically put this query in and you will get that particular answer out. So that's basically using the where conditional or where filter. It's called filter in SQLite. So basically we have the normal statement, where, age, or whatever, blah, blah. The big issue is equals. So again, if you're new to programming, normally when you do equals, a single equals means one that you force a variable to equal something else, right? So normally, like num equals 1, num now has a value of 1. If you're doing an if-else statement, you're doing a statement, if num equals 1, you don't use equals, you use equals equals. So if num equals 1, then do something, right? Syntax. Anyways, in the SQL world, you don't do that. Where a column equals, single equals, value, that's what you do. Anyways, it's stupid, but it gets tedious. Let's see here. Update. Oh yeah, so this is the fun one. This is where you got to be careful. Whiteboards. Whiteboards are your friend. So this is where primary keys become very, very, very important. So what the update does is the update changes values in a record, right? What happens when you need to change the email address in somebody's record? What happens when you need to change the age in somebody's record? So on and so forth. You use an update. So update table, so update, whatever the table name is, set the column to a value where the column equals a different value. So anyways, let's go over here. All right, so select all from student. So we have Bob, Bobby, blah. So anyways, let's say Bobby isn't a boy. We thought Bobby was a boy. Bobby's a girl, and so it should be Bobbie. So what we need to do is we need to change just that value here. The thing that you're going to have to be concerned about is what if you had multiple Bobbies, right? So let's say insert into student name, age, allergy, values, Bobby. And let's make this Bobby 18 and doesn't have an allergy. All right, so now we do select all from student. All right, so we have Bobby, 15, is allergic to dogs. But we also have Bobby, is 18, isn't allergic to anything. This Bobby up here, somebody messed up, supposed to be a girl. We have him as a boy, so we need to change that. So if I do an update where I say, wherever there is Bobby, B-O-B-B-Y, change that to B-O-B-I-E, that will change both Bobby and Bobby. That will be bad, right? And so that's why the row ID is important, right? Select all from, select row ID, let's just do name, from student. Okay, so now we have that row ID. So we can use this as a unique ID. So even Bobby, the names are the same, right? The row ID is different, right? So if I did update table set column, yeah. So update student set name equals BOBBIE, where, let's make sure it's been a little while, where name equals BOBBY. Hopefully I did that right. Okay, so that goes through again. And so the problem is I then just changed. So basically anywhere there was Bobby, it then changed to BOBBIE. So both Bobby and Bobby were changed. And so that's one of the problems you can run into with updates and updating way too damn many things. And that's where the unique ID is important. So what I can do here is instead I can say set name back to Bobby, BOBBY, where row ID equals 9. So we're going to put 9 back to being a boy's name, hit enter, and now we do so if we do the where name equals, that will change anywhere where the name is identical. If we do the row ID, that's why having these unique IDs is so damn important. So when you create things like the web interfaces that we will in the future, you're always going to be using a primary key or a unique ID for when you do updates or deletes or anything to the database. Because if you don't do that properly, again, disaster. Again, imagine if this is a CRM solution or whatever that has like a million names in the back end. Or what if this is your email list, right? Again, that's what a marketing person might do, right? SQLite is so easy to implement that they might be like, oh, I'm going to import, again, all these CSV files into a SQLite database, and then I'm going to send out my news blast using this as the data store, right? If they then need to go in and start making modifications, if you don't modify properly, if you don't run the update properly, again, disaster will follow. So anyways, all you do to update table name, set the column to the value where column equals a different value. Generally, almost always, you want that to be the primary key. Or you might be doing this to sanitize data. So let's say we have t-shirt sizes, right? So people are plugging t-shirt sizes into your database. Some people put L, some people put large, some people put larg. And so you want to standardize that. So you say, column, 1 equals large, where column 2 equals L. Column 1 equals, large, where column 2 equals larg. Right? You can try to use that to try to sanitize data. But again, stuff to be very careful about when you're thinking about it. Let's see here. Deleting. Don't mess up. Don't. Delete from table where column 1 equals value. That's the exact same thing that I kind of showed you before with the update. So you're going to delete from student where name or whatever equals value. So again, if we come back here and we're taking a look at this, and I do delete from student where name equals, I don't know. Well, now we got 2 different ones. But anyways, you could do like, again, Bobby. Anyways, so I do that, right? It's going to delete all the Bobbies. We do select all, and 1 Bobby's gone, right? So if you have multiple Bobbies, all the Bobbies would be gone. Again, that's the same thing. You want to use the row ID. All this stuff is very simple. Again, if you can learn HTML, you can learn SQLite. And if you can learn SQLite, you can learn almost anything else in technology. So again, you either use the row ID or you use that primary key. That is the value you're going to be deleting stuff off of. Let's see here. Joins. So basically joins is where we get into this thing, right? So in this particular example, so we have students and we have allergies, right? So that's one of the things, like there might be a lot of instructions with students. So students may have allergies. Students may have all kinds of different things. So you want different tables for those different types of things. So students may have allergies, and students may have learning disabilities, and students may have, again, a gazillion different things. And so you can have individual tables for all of those different things and what you're supposed to do about those certain things. So let's see here. Yeah. Basically, with this, so again, if we take a look at this, we do tables, dot tables. So not only do we have student, but we have allergy, right? So we do select all from allergy, semicolon. So we have three allergies in here. We have peanut, we have dog, and we have sun. The rule is don't feed the peanuts or keep them away from dogs or put on suntan lotion, right? Basic stuff. But the thing is, instead of having this replicated in your entire student table, you can simply have the student table associated with these, right? So again, if we do a select all from student, select all from student. So we see Bob, right, 12 peanut, Bobby 15 dog, Frankie 14 son, Nancy 14 cat, Timmy 14 peanut. So basically what we say, this is the allergy that we have, and then we can join the two tables together so they basically come to one table. So that is where, again, it's not complicated. Just a lot of word salad, right? So the first thing is select all. This is going to be a bit of a disaster. You're going to see it though. Select all from table one. And then so this is going to be student. Select all from student. So this is called left outer join. So we're not going to get a lot into joins today because joins are their own worlds, but joins are where you join two tables together. Again, you can go do a video search and you can learn some different things about joins. Left outer join. What that means is we're going to join the left-hand table that we're talking about, right? So table, student table. So this is going to be student table. So we're going to left join student table to allergy. Left outer join table 2. So left join student to allergy on student.column. So this is the table name, and then this is the column name. So student.allergy, where student.allergy equals allergy.name, right? So the name of the allergy in the student table with the name of the allergy in the allergy table, and that will provide us a linked result, right? So let's see if I can do this without mucking it up. Oh, I gotta get over here so you can see what's going on. Okay, so select, I already messed it up. Select all from student, left outer join allergy on student dot allergy equals allergy.name. There we go, that's not too bad. So basically select all the rows from both the student and the allergy table. Student, left outer join, blah, blah. So we do this. And so now look at this, right? We have two different tables. And now we get them in this nice thing together, right? We have name, so Bob, age of 12, allergy is peanut. Name of allergy is peanut. Rule is don't feed peanuts, right? Bobby, dog, keep away from dogs. Frank, son, put on suntan lotion. Nancy, cat. And so this is going to be an interesting one to be thinking about. And this is one of the things that you have to be careful about, again, with data, is what happens if you put an allergy, so somebody's allergic to something, but then you don't have a rule for it. Again, that's when we think about auditing systems. This is the kind of thing that you need to audit for. The parents told you she's allergic to cats. Why did the instructor allow her to pet cats? Because somebody forgot to plug in a damn rule to the database table. That's why. Again, And then, Tommy and Jenny and Trish, they don't have anything. And Timmy, Peanut, don't feed peanuts. Why this can be concerning, especially from an auditing standpoint, is right. So select all. So we're selecting all the column names: a name, age, allergy, name of allergy, and rule for allergy. But generally, you don't want to pull all this information back. For security purposes and for performance purposes, you only want the data that you actually need, right? So normally what you would do is you would do select, let's say, student.name. So from the student table, I want the name. Let's say from you could do this from the allergy table dot name and allergy table dot rule. Select student name, left outer join allergy on student dot allergy equals allergy dot name. All right. Oops. What does it say here? Allergy, oh shit. Select student.name, allergy.name, allergy.rule, left outer join allergy on student.allergy equals allergy.name. Oh, what the fuck did I do? Left outer join allergy on student. Left outer join allergy on. Oh, near left. Select student.name. This is the fun of doing this kind of stuff in real time. Let me just go back here. Let me just do allergy.name. Left outer join allergy on student. Left outer. I did something wrong. Oh, damn it. Oh, anybody see what the hell I'm doing wrong? Select student.name, right? Allergy.rule. Oh, Jesus Christ. Allergy. No. Select student.name. Oh, select student. Jesus Christ. From student. There you go. That's simple and Eli can do it. Anyway, again, just remember, computers are not smart. They only do what you tell it to do. So if you're an idiot. Anyways, so select student name, allergy rule, from student, right? That's the table, from the table, left outer join allergy, where student.allergy equals allergy.name. So we can see Bob, don't feed the peanuts. Bobby, keep away from dogs. Frank, put on suntan. Nancy, was Nancy there? Yeah, see, Nancy is allergic to cats. But when we do it this way, we get no commentary that she's allergic to cats. So poor little Nancy is going to get a whole bowl of cats on her lap, and all hell is going to break loose. So anyways, this is the basic idea of joins. We're going to be doing more with joins going in the future, but this really is like the power. When we talk about relational database systems, and then we talk about this whole schema type system, this idea of every single table is supposed to have like the minimum amount of data that it should. again, allergy. So allergy would be, the name of the allergy, the rule for the allergy, what to do if a student has that allergy, points of contact, right? That would all be in the allergy table, and you're able to get all of that information again by doing, it's called the left outer join. So we talk about the left because there's inner join, there's cross joins, so many joins. We're not doing a join class today. But anyways, so the left outer join, when you do the left outer join, that joins the left table, or the joins to the next table on the left. That's that. That is a join. Oh, probably just talking word salad at this point. Let's see here. Okay, any questions on basic SQL, structured query language up until this point? Any questions at all? We're going to get into Python. Python's very simple. Again, once you know SQL, we're just using Python to run SQL. Any questions? Okay, we're just going to go to Python then. With Python, again, it's going to be pretty simple. We're going to have two examples. We're going to show you how this works. One of the big things when you're running SQL through Python is make sure to commit changes when you do updates or when you do inserts. Again, it's a weird thing. Like until you tell it to actually do it, it's like it'll run it, but doesn't really run it until you commit it. I'll show you that in a second. Make sure to close the connection. So remember, there's sessions. Whenever you connect to a database server, whenever you connect to a database, you open a session to that database. You should close the session to the database. If you don't, you could run into problems. And then we use question mark values to prevent what are called SQL injection attacks. I will show you that when I show you the code. And the final thing, again, ChatGPT is your friend. ChatGPT is not intelligent. It's not artificial intelligence, but it's damn fine for auditing your code. If you can't figure out why your Python code is not interacting with your SQLite database properly, copy, paste into ChatGPT, and it does a wonderful job of telling you how you're stupid. So anyways, let's take a look at the SQLite, the insert. Okay. So this is pretty simple. Again, all of this is up on the GitHub account, and this is all commented here so you get a better idea of what's going on. So anytime we deal with Python, you do have to import whatever module you're going to use. We're going to import SQLite 3 module. The next thing that we need to do is we need to create a connection to the database that we're going to be connecting to. Now, if we just call the database name, do remember this is going to be in your root directory, right? So with Python, your root directory, your user's root directory is generally the working directory for the Python script. And so it's just going to get dumped there. So when we say example.db here, that would basically be if we go to my computer and we do Eli, right? In my Eli folder, example DB will show up. I don't think I've played with this yet. Yep, so it's not there yet. So I do not have an example DB. It will show up when we play with this. So we need to create a connection. So con is going to equal SQLite3.connect to the database. So we're either going to connect to a database that already exists, or we're going to create a database. Simply by doing this, we're going to create that database. We're then going to use cursor. Cursor is a method within Python that allows you to actually interact with the database server. When we're sending SQL statements, we need to use the cursor method. So we're going to say cursor equals connection. So that connection we created, dot cursor, and this is what we're then going to be using going forward for interacting with the database server. So cursor dot execute. The first thing here is to create a table if it doesn't exist. So again, this is one of the nice things if you're creating, again, especially very basic utilities. We're going to be creating a lot of things like, network diagnostic tools. Again, network diagnostic tools are just great for learning how to code because it gives you dynamic information. And so one of the things, if you have, let's say some kind of diagnostic tool, one of the things you might want is for a table to be created if it doesn't exist. Oops. What the hell? Why is somebody doing a whiteboard? Why can somebody do a whiteboard? Oh, allow participants to share whiteboards. Oh, what are people doing? What are people gonna make me lose my goddamn mind? Oh yeah, that's not fun. Again, I will remind people, I know in this modern world, it's the 99% against the 1%ers. And of course, in our modern world, we don't teach our kids math. So the kids don't quite understand what the hell 1% actually means. So they think all authority figures are the 1%. That's not how it works. Again, one of the things I'll say, as an instructor, for your professors, for your instructors, for your bosses, this is hard work. It's really easy to be like, oh, look at that dumbass. Let's throw some spitballs at him. Um, this is hard to do. Don't fuck with things, please. Anyways, again, as I once told, I was doing the live shows at one point, and literally I had one of the people that communicated with me during the live show. And again, this was like 8, 10 years ago. And the student was like, Eli, I don't know what to do. I was like, oh, what's going on? He's like, well, I'm in Syria, and all of my good professors fled for their lives. And the only professors that we have left suck. Eli, what do I do? I was like, first, go into the professors that are left and say thank you for sticking around. And then two, I don't know, figure out if you can do some tutoring or training other people. Again, it's very easy to be like, oh, my teachers suck or whatever. It's like, yeah, well, the other professors may have fled for their lives. So, anyways. Connection. We're going to connect to the database. We're going to create a cursor. We're going to execute. Okay, so this is a really cool statement right here. Create table if not exists. So basically, this part of the statement right there is it will create a new table. Oops, it will create a new table if one doesn't already exist already. So again, this is great for the like utility. If you don't want to do all this whiteboarding crap, it's an easy way of doing things. And then you create the table. So people, so we create a table for people in the example database with a column of name, age, and sex. That's all you do there. And then we going to execute here. So cursor.execute, insert into people, that database that we created, name, age, sex, values, question mark, question mark, question mark. So it's important to understand here. You can actually put the values in here. We could use F strings. We could use F strings or however else you want to do it with concatenation and put values directly in here. The concern is if a hacker is somehow able to compromise the values that are going in here and you're plugging in a SQL statement directly into your database, they could do what's called a SQL injection attack. And so what a SQL injection attack does is where they put in a certain string of characters in order to basically kill the statement that you're trying to run. They add their own statement, right? That is now operating at whatever privilege level you've allowed. And since it's SQLite, there are no privileges. So basically it's root level access and all hell takes place. Right? So you can do that. Again, if this is like some kind of network monitoring thing, you're the only one messing with it, maybe that's fine. Almost anything else, and for any other reason, you do question mark, question mark, question mark, you close the single or double quotation marks, and then you do comma. And then here, you put in the values for the question marks. And so all this is an index value. So index 0 question mark is Tom, index 1 question mark is 33, and index 2 question mark is boy. Right? And so what that does is that inserts these values into the SQL statement in such a way that you're not going to run into SQL injection attacks. Hopefully. Basically how it's done. Anyways, then we do con.commit, right? And so what this is going to do is it's going to commit these things that we've executed, and then we are going to close, right? So then if I run this, there you go. So it ran. I don't get a response because I didn't program a response in. If we go here, we can now see we have the example DB. So example.db. Now it is important to understand what this .db. So this is an extension. We are using this extension just so that we know what the hell we're dealing with. Again, in the programming world, you do not have to put extensions. I could simply put example, that's it, but then I might not know what I'm looking at. Again, an important thing with this is we can do open. Let's see, open it with a text editor. There we go. I don't know if you can see that, but I literally open this with a text editor. And again, this is actually what pops up just in the text editor, just to show you how insecure this information is. You know, table people, create, and then we have Tom, boy. We have some basic information, like simply opening this up with nothing more than a text editor, we can actually take a look at some of the information on there. That's why we have to be careful. If we go over here now, though, let me open up a different tab, new tab. All right, so here I can do SQL Lite 3 example.db. I can do dot tables. So it shows me the people table. And schema for people. So it shows create table, name, age, sex, and I can do select all from people, semicolon, because this is a SQL statement. And then it shows me Tom, 33, boy, right? So basically I was able to plug all of this information into the system simply by using Python. And again, all this stuff really is just copy paste. It's just copy paste. One of the things that I'm going to be doing as we go along with these classes is I'm going to start creating more cheat sheets for Python, for SQLite, for Bottle. There's a lot of things that you do with most of these, languages that you're going to run the same commands or whatever basically 90% of the time. There's going to be like 15 commands that you're going to run like 95% of the time, and then some individual use cases. So I am going to like create notebooks or whatever going into the future. But that's the thing with this, just to realize, is you just go in, basically just copy and paste, and as you understand Python, it starts to work out better. Let's see here. Then we go over to select. So this is going to be selecting from the database. So import, let me add in a couple more things, right? So we're going to say Tim is 13, also a boy. More on this. Then we'll say Phil is a boy, I don't know, 17, or on this. Gonna add this up. Sue is I don't know, 20, is a girl, is a Gil. Just adding some things for the next sequel. Sammy is 13, also a girl. Okay. Now we have some things for the select example. Okay, so now we go to the select example. Okay, so import SQLite 3 as we did before. We're going to create a connection. So we're going to connect to that example.db database. Cursor is going to equal connection.cursor. And then you'll notice we're not creating a table here because hopefully the table already exists, right? And then we look at these queries. So yeah. It's all pretty simple, right? So query equals, so cursor, so that cursor.execute, select all from people. So we're going to select all the columns from people. Query is going to equal that query that we created with the method fetch all. So basically all the records that we got here, we're essentially going to turn all of those into a list, and they're going to print out that entire list, right? Then return a specific number of records. So this is all the records we get back. So again, query equals cursor.execute, select all from people, query.fetch many. So fetch all, fetch many. How many records do I want back? So if I want to limit this for whatever reason, so this will be the final ones that you got. So you can do sorts. So anyways, so the final ones, so 3. We want the last 3 records. We're going to get the last 3 records. I'm going to print that out. If we want a single record, we do cursor.execute, same thing, and fetch 1. This will be the final record that we got, right? We're going to print that out. And then if we come down here, we can also do a where clause. So query equals cursor.execute, select all from people where age is greater than question mark. We do comma, we do parentheses, 20, so 20 is here, and then we do a comma. Now this is a weird thing. Again, it's syntax. Why? Who the hell knows? It's not me. You'll notice here when we do the question marks, Sammy, question mark, you do the question marks, Sammy, comma, age, comma, girl, nothing, right? So you only do as many commas as you need to actually separate. For whatever reason, when you do select statements, you always put a comma at the end. So it's going to be question mark. So 20 is going to go in here, and then you can put a comma after that, or it will fail. And that's then we're going to do the where, and that will fetch all, and we're going to print out the query. So again, all pretty simple stuff. Copy and paste. So we take a look at this, right? Fetch all. So what you can see the brackets here. So this comes back as a list, right? So index 0 on the list is Tom 33 boy. Index 1, Tim 13 boy. Index 2, Phil 17 boy. Index 3, Sue 20 girl. Index 4, Sammy 13 girl. Right? So that is bringing us all the records back. Then we do here, we only wanted the 3 records back, right? First 3. So Tom, Tim, and Phil, they're the ones that come back. And then with this one, we only wanted 1. So we get Tom, that comes back. And then finally, at the end, we wanted anybody who was over the age of 20. So we take a look at this. Right, so Tom is 33, Tim's 13, no, Phil's 17, no, Sue's 20, but it's older than 20, so she's not good, and Sammy is 13, right? So if I go, let's say I put 18 here, and I run this again, where that where statement is, we now get Tom, 33 boy, Sue, 20 girl, and that's how we can do select statements with Python. And so that's basically all there is with Python. And again, with all this stuff, we just build on top of it, right? So we have that Bottle web app framework that we learned before. So you can create the HTML forms. We take the information from the HTML form, we send it to Python. Python then formats that into a query that sends that structured query language to the database. The database then responds, again, with the information. We then use Python, fetch one, fetch all, fetch many. We bring that back. We then format that. And then with that information in Python, we then convert it into HTML or whatever the response is going to be, and then send it back to the user. And so that's where it's like all of these simple things build on each other to create the more complicated applications. So that is the end of the class. Now we're going to get to the labs. Does anybody have a question up to this point? And Jock does. Jock, what's up?
In your code, when you say fetch, so again, it's the fetch one. I thought you were saying you're fetching from the last 3 entries or the last 2 entries or the last entry by itself. I thought you would fetch Sammy, not the first 3. Because when you were saying fetching the last entry, Sammy would be the last entry. Am I misunderstanding that?
What's happening here? So if you do fetch one, it's fetching the first entry that it receives back based on how it's ordered by. All right, so we just talked about that order by thing. So basically when we're fetching actually, so it fetches Tom as 1 and Tim as 2 and Phil as 3 and Sue as 4, right? So Tom then is in that first position. So if you do fetch 1, it will get Tom back. If you, let's say, ordered by age. So if you let's do it this way. Select all from people, order by age. Let's see how that works. So then, since we reordered it, Tim comes up in the first position. So that's the one that comes back. So you get either the first one or the first, however many, with the fetch many, you get that from the first that comes back. Does that make sense? By how it's ordered.
Yeah. Yes. So how would it look like if you want to fetch the last entry? How would you put that?
So whatever, ADESC, so that was descending. So yeah, so now fetch 1. Yeah, so now Tommy is 33. So yeah, so that's descending. So let's say we could do by name descending. Maybe that'll get us a different one.
Because the last entry you put in was Sammy, and I'm trying to figure out how would you get Sammy? You need to get her.
So if you want Sammy, then you would do row ID descending.
Oh, okay. That's
There,
okay. I
now
got
we
you.
get Sammy. Yeah, that's where like again the principles of all this are dirt simple. It's writing it out to make sure you get the result that you're looking for. Yeah, so the row ID, so every one of these has a row ID. So then yeah, if you sort based off of row ID, then you could pull it that way.
Okay. Thank you. That was the one thing I just had a question about because when you said fetch and it said the last one in, I was like, oh, the last one in you put in was Sammy, but it didn't come out that way. So it always fetches from the first entry all the time when you says fetch one. It goes for that first one, that first entry first.
Yeah, yeah.
Gotcha. Okay, thank you.
Okay. Any other questions? Any other questions? Before we get into labs. Okay, no other questions? We will get into the labs. So again, with these labs, you should just need Python installed. They work on my Mac. I'll tell you, they work on my Mac. They should definitely work on Ubuntu. And if you're using Windows, well, I don't know. You're using Windows. Should work on Windows too. I don't know. So anyways, with this, we have some functions. Again, functions, as we've dealt with before, are very useful as we start creating more complicated things. So basically what we're going to be doing here is we're going to be inserting data into a database. Again, basically the student database, and then it's just going to be reading from that database to show us what's already in there. All right, so basically I can click on this run. So name, again, Bob, age is 12, allergy is peanut. And so then I plug this information in, and now it shows me in the database, this is the one record that we have. This is a while true loop, so it allows me to plug something else in. So I'm going to say Sue, she's 22, she's allergic to cats. Again, while true loop, it then now shows me Bob, 12 peanut, Sue, 22 cat. I can do Phil, 20, dog. And basically all this is doing. And so what this is showing you how to do is from the command line, you're able to input information. That information is then going to be sent. It's going to be inserted into the SQL database. And then all we're doing is a very simple select statement to pull those values out just so you can see that they're in the database. Again, this is not really a usable app. It just kind of shows you, again, that inserting and selecting. So we take a look at this. Import SQLite 3. The first thing that we're going to do is we're going to do this whole connection. We're going to create a table if it doesn't exist, just to make life easier for us, right? So with this, we're going to do lab.db. So lab.db, so we're not overwriting anything, do anything weird. So con equals SQLite 3 connect to lab.db. That is going to be in your root directory. Cursor equals connection to cursor. Cursor execute, create table if it doesn't exist. If not exist, student, name, age, allergy, as we've done before. Connection commit. So if we don't commit, this isn't going to happen. Make sure you commit, and then make sure you close. Then basically what we're going to do is we're going to come down here to the while true loop. So we have these functions here. We're going to call them in this while true loop. So while true, this means it's going to continuously loop. Name equals input function. It's going to ask for a name. Age equals input function. It's going to ask for an age. Allergy equals input function. It's going to ask for an allergy. Then we're going to do insert. This is the function. So define function. So we have an insert function. So the insert function, we're going to send it name, age, and allergy. So up here, we're going to send name, age, and allergy. We're then going to come here and take a look at this. So we're going to have connection again. So we're going to connect. So connect SQLite to the lab.db. Cursor equals the cursor. Cursor.execute. So insert into student, name, age, allergy, values, question mark, question mark, question mark. So name is coming from name, age is coming from age, and allergy is coming from allergy. Con.commit, so commit that and then close. So we're not doing any kind of return here. We are just submitting that to the database, and that's it. Again, if we're doing this in a real production environment, we do try except statements, but I'm trying to keep this simple for you guys. So we're going to insert. Then query. So query is going to equal fetch. So we're going to go create a fetch function, and the fetch function is going to fetch the information for the database. So again, con equals connect to lab.db, cursor is cursor, query equals cursor.execute, select all from student. So we're going to select all the records from the student. Query then equals query.fetch all. So all these records that come back, we're going to turn that into a list. We're then going to close the database, and then we're going to return that list that we've created. So that list, right? So query is the list that comes back from this function, and then we're simply printing out that list, and that's what you see at the end, right? So basically when you run this, name, Tommy, age 66, allergy is, I don't know, class. I hit enter, and so basically this is just coming back as a list, right? List brackets, index 0, index 1, index 2, index 3, and then if you understand how to deal with lists, you can play with that more. Does everybody, more or less, get what's going on with that particular lab? Okay, let's go to lab 2. Lab 2 is search. Okay, so for search, basically what we're going to do is, let's say we want to look for information. So name to search, B. This shows us some different information. So if I want to search for a name with B in it, we have Bob, 12. So this brings us back the full list. This brings us back basically each item in the list. And then we have name is Bob, age is 12, allergy is peanut. Basically show different ways to demonstrate this. Here, let me do one thing here with this insert. Let me run this again. Let me say Billy, 77, again, peanut. Oh, look at that. I actually put a bracket in there. Should still accept it. Yeah. Bobby. There we go. So we have some more values in there. Okay, so now when we run this, again, if I search for B, there we go. Now we have some different values. So when it prints it out, I just want to show you the different ways that this can be printed out. Again, for you to be thinking about how you want to be dealing with the data. So it prints out just the list. So if I'm looking for somebody with B in it, we have Bob, we have Billy, and we have Bobby. These are the items coming back as a list. Then for each item in the list, right, we put that on a different line. So we're looping through this list to print them out. And then once we understand how to do that, we can then print everything out in a much more nicely formatted fashion. So that's the only reason that we're doing this 3 different ways. Again, trying to give you that feel of how to format data as it comes back. Okay. So import SQLite 3, connection, connect to the lab.db. Make sure you're connecting to that database that you created before. And just like I did, plug in a whole bunch of different names with a whole bunch of different information so you can actually do a search. If you only put in one name, then you can only search for one name. You get the point. Anyways, yeah, I should not have put that in here. I should not have put that in there. Actually, I probably shouldn't have put any of that in there. Anyways, again, beta classes. Anyways, it creates a table if it doesn't exist, but if it doesn't exist, you can't search for any items. So, yeah. Let's see here. So while true, name equals input, name to search for. Query equals fetch the name, right? So fetch function, the name value. So the name that we put in is going to go up here. Then we're going to print out the query. So before we do that, let's just take a look at this for a second. So again, this is all pretty simple. Connection equals SQLite. We're connecting to lab.db. We're creating the cursor. We're going to execute, right? So select all from student where name like. So again, that like is that search thing. Question mark. And then we have to do this weird little ass F string. So basically we had the name. So the value of the name that we're putting in, Bob, Bobby, B. And so we want to make it a wildcard thing, so we get back all possible options. So we do an F string, single quotation mark. We then basically we wrap the variable value within those percentage signs. So like we did before, percentage sign, then we do squiggly bracket, name. So the name that comes in, close percentage sign. Right, so basically what this is going to do is it's going to be basically here, it's going to be percentage sign, B percentage sign. So anything with a B in it is what is going to be found. Right, query equals query.fetchAll. So basically we're going to have a list of all the items that came back. We're going to close the connection, and then we're going to return this list. So here we are going to be returning this list. Once we return the list, we're simply going to print that list as it is. The list as it is, we're just going to print it out. No formatting. You see the list, so you make sure you got it. Then we're just going to do print here, just put a line, put a space in between. Then, since this is a list, we're going to do for record in query. So query is a list, and then we're going to print out each index in that list. So Bobby's record and Billy's record, whoever's record, right? That whole thing. But it's gonna be within that set. It's gonna be within those parentheses still. So that's where it can come down here and we can make it prettier. So print name, so name : /T. So T is a tab space, right? So we want to try to format this. Print name : tab, age : tab, allergy, we don't need a tab. For record in query like we did before, print F string. So we're going to do record 0, right? So record 0 is going to be the name. Then we're going to do a tab. Record 1 is going to be the age. And then we're going to do the tab. And record 2 is going to be the allergy. And we don't need a tab, right? And that's what prints it out nice and pretty. So we take a look at this. Again, we search for B. So this comes back as the entire list. This comes back iterating through the list. So Bob is the first one record, and Billy's the second record, and Bobby's the third record, right? And then this is how we format it pretty. Name, T, age, T, the actual value for name, T, 12, T, peanut. Billy, 77, peanut, Bobby, 55. Yeah. More or less understand what's going on? That's why I do like having a real physical class in front of me, is I can see the people sleeping and I can hit them with a koosh ball. I grew up in the 1980s where our teachers smacked us with koosh balls. Anybody remember a koosh ball? Anyways, I hope you're all awake. Let's see here. Okay, then the final one, we don't have any question, is where we create our own little note-taking app. So this gets a little bit more complicated. Okay, so import SQLite 3, or actually let me show you what this is. So basically when we run this, you get an action. You can either search or you can insert. So I'm going to say I want to insert a new note. And what is the note title? A note for class. What is the note message? This is a note for class. So added a note for class. This is a note for class. I can do another, let's say insert Bob, and say Bob is a cool cat. Hit enter. And then again, so basically if I do insert, it'll send me to a place where I can add a title for a message or a note, and I can add the note itself. If I do search then, and do search, it asks me for a search query. So I can say, I want to know any notes I have about Bob, and I can hit enter. So it shows me Bob. Bob is a cool cat. So I didn't format this, I'll let you guys do that as extra credit. But right, so again, like if I do insert, oh, Bob is so cool. Have I told you how cool Bob is? All right, so I added that. I can do search. I can then say Bob. And so it shows me Bob. Bob is a cool cat. and then it shows me basically anything with that particular value in it. So basically, this is a way that you can create a very simple command line note-taking app and then be able to search for any notes that you have created, which is pretty close to actually a useful product. Again, your extra credit will be turning it into a useful product. Okay, so with this one, we are going to create the node database because we actually need it. If we don't have a database, this all fails. So we're going to connect to note.db. We're going to create the cursor, create if not exists, note, title, and message. So note, title, and a message. We're going to commit, and we're going to close. We're then going to come down here. Basically, while true, action, so we're going to have a variable name called action equals input, and then we're going to say action, search, or insert. So if action.lower equals search. So I'm doing the lower method here, because again, what happens if people capitalize or do something weird? So if you just standardize, you just take whatever they put in, lowercase it, makes it easier. So if it equals search, we're going to do the fetch function. If action.lower equals insert, we're going to do the insert function. If action.lower equals exit we're going to break. So that's one thing we haven't had in our projects before, is a way to get out easily. And else, basically, if it's not one of these commands, you're going to get that command is not understood. So again, if I do here, and it asks me for something, and I do blah, it'll say blah, 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 command not understood. If I do exit, it then breaks me out of the loop. Okay, so let's do the insert first. Again, if we do the insert, what's going to happen here? So we do the insert function. If insert, we're going to go to insert function. So the insert function, again, pretty simple. Connection, node database, cursor, title equals input, what the note title is, message equals input, what's the note message, cursor.execute, insert into note, title message, values, question mark, comma, so title, comma, message. So the values that you put in here, so this is where it's going to be asking you for those values, and it's going to be plugging that in. We're then going to commit, because if you don't commit, it doesn't happen. Then we're going to close. Then we're not doing a return here. We're simply printing out added, title, and message. Again, with a lot of this stuff here, the old coders will say this is crap code because we're not using try except statements. Again, if you're doing this in the real world, you would want something in here for if this fails, but hopefully this is not failing your system. These are labs, so hopefully it'll work properly. So anyways, this is all you get when you add, you insert. We come out down here to fetch. And so basically, again, all simple, connection, node database, connection cursor, value. So basically, what are we doing the search query for? Input search query. So query equals cursor.execute, select all from note where message like, question mark. We then do that F string again. We wrap the value that we asked for within those percentage signs. Then we do query equals query.fetch all. So what comes back, we turn that into a list. We then close, and then here, again, we're not even returning. We're simply going to just print that out on the screen, and that's where you get all of those different items, right? So again, that's where, if we run this, again, I type insert. I do Bonnie. Oh, I don't know Bonnie. Bonnie is also cool. All right, I can do search. I can search for anything with a B-O in it. And then we can see Bob is a cool cat. Bob is, I told you how cool Bob is, and Bonnie is also cool. So those values come back. That's one thing here is, again, you'll notice is where message. So when we created this table, we have title and message. So this is only searching in the message. So if you had BO in the title, but not in the rest of the message, that wouldn't show up on the results because you're not searching there. So you can play around with the whole ands and that kind of thing and see how that works. And so that gives you, again, a basic little note-taking app that you can play with and modify and that kind of thing. So Yep, there we go. That is a class. So we've learned SQL, structured query language. We've learned how Python interacts with SQL, and we've gone through a couple of labs. Is there any question at this point in time? Questions? Really, is Jock the only one that's awake? I feel like he might be the only one drinking coffee out of this group. Nobody has any questions. Okay, let's see here. Um, okay, nobody has questions. So I will stick around for like 20 more minutes if you all want to do the labs. So again, these labs are all on GitHub or where is it? If you go to GitHub, we have the lab book. So lab book in PDF. You can come here. Again, you can, I recommend that you print these out, or again, if you have another computer. Basically, the idea is this should be somewhere else, and then you tippy-tap type on your own computer. Again, if you copy and paste, that misses the entire damn point. When you are Picasso, you get to copy and paste. If you're watching this class, you're not Picasso, right? So anyways, do not copy and paste. Have this up somewhere, whether it's on an e-reader or you print it out or it's on another screen. You type this into your VS Code. You get your VS Code to do what it's supposed to do, and we go from there. If you guys have any questions, again, I'll be around for about 20 more minutes so you can play around with this. But again, it is important. I swear it to you. Like, you think it's going to be the big thing. You think it's going to be the big things that's going to kill you as a technology professional. I mean, how many tech professionals have literally spent an entire damn day only to find out they missed one single quotation mark somewhere? That is the real world. So anyways, that is about it. Can you elaborate briefly on what the deal is with YouTube? Well, we're at the end of the class, so I guess so. I don't know, my deal with YouTube. So basically, YouTube, as far as I'm concerned, so YouTube used to be good. To be clear, I was not always negative. I was not always negative. I was a young, bright geek one time. That was a long damn time ago. Anyways, YouTube used to be good. YouTube used to be good. Again, where I got world famous off of was by being able to create educational content that made the world better. Again, I've met people from Africa and Pakistan and India and inner cities and a whole bunch of white boys too. But anyways, it's cooler to say the Africans. Anyways, um, right? That my content really made their lives better, right? And I was able to create content that made people's lives better, and I was able to get paid. And it was under a system back then where the recommendation engine used to be based off of essentially who you subscribe to. It was based off of who you subscribe to and how much of their content you watch, right? So what were your actions? If your action was to subscribe and watch content, you got more, right? Unfortunately, that wasn't enough money for them. Because again, it's kind of like with email, right? Everybody uses email. Very, very few people are addicted to email. Some people are, some people are. Most people are not addicted to email, right? It's a useful service you use every day, but you're not addicted to it, right? And the problem is, right, if you're doing an ad-based system where you're getting a fraction of a cent per every ad that's viewed, email isn't a good way to go because you're not getting that many views, you're not getting that many impressions. So basically, what they did is they changed the algorithm. It was a couple years ago at this point, a few years ago at this point, to be based more off of clickbaitiness, right? And this is where, again, this is where, God bless them, the Tim Pools of the world and a lot of the commentary videos really took off. Is what YouTube realized is they could get you to click more based off of pumping you full of the exact same type of content. Again, however you frickin' feel about it, I really don't care. Trump, Fauci, Biden, pick your side. I don't give a damn. But what happened was if you started creating that kind of clickbaity type content, that is the type of content that YouTube would drive viewers to. And so that's where, again, back when I was in the barn, so 4 years ago, The YouTube channel was dying. I was doing classes. I was doing SQL classes and all kinds of classes, and the channel was dying. Month after month, the channel was dying. I was stuck in the house, didn't know what to do. So I figured I'd do a Hail Mary pass, and I'd be a Tim Pool too. It's like, hey, a Tim Pool, that doesn't seem too hard. Let me try to do that. I crap you not. When I started talking about Trump and Fauci and the rest of that horse crap, in 30 days, I tripled my revenue and tripled my views. So I had a channel that was dying month after month of me putting out tech content. My channel was dying. As soon as I start saying stupid crap about Fauci, like it's not like a little bit. It's not like it went up like 10% and I recovered my channel after a year. 30 days, I tripled the revenue, tripled the views. I could make a lot of money sitting here screaming about Trump in Arlington Cemetery, right? But who the hell cares? Again, like I say, like Trump in Arlington Cemetery is the perfect example of the idiocy currently going on, right? Again, I'm a vet. I'm a vet. Father's a vet. Grandfather's a vet. Great grandfather's a vet. Veterans going all the way back to the Civil War, right? Confederate fucking dragged one of my forefathers out, fucking blew his head off in front of, his family members, right? That's how far back I'm a veteran, right? Anyways, Trump goes to Arlington Cemetery at the request of some parents and takes some pictures and puts it on Trump media. Eh. Are there some interesting question about rules and politics and military being used in elections? Yes. Is it that big a deal to anybody that has a life? No. But again, if you open up the news feed, oh god, there's a zillion fucking opinions about Arlington Cemetery. And again, Kamala Harris has, it's just all, and that's the thing, that's the problem with YouTube. That's the problem with the modern clickbait social media system is it's the lowest value communication possible. The way that I think about it is what happens if Mark Zuckerberg was responsible for child nutrition in the US, but he's responsible for child nutrition in the idea of making them eat as much as possible, right? What would happen, right? Candy bar sales would go through the roof, and depression, obesity, suicide, heart attacks, and 16-year-olds would also go through the roof, right? The food industry would be doing better than ever as the kids are getting heart attacks at 15. I think that's what's happening in basically the social media and really the media world is just imagine just simply feeding society sugar and just driving that, and that is the only thing. Again, like even I know you'll see like Jeff Gear, I like Jeff Geerling and all that, but even if you look at Jeff Geerling's content, again, he's a really smart guy, works on Ansible, works on a whole bunch of stuff, but look at the value of his content over the years. It's really fucking stepping down. Yes, he still talks about Raspberry Pis, which you could say is like high level, sort of. And now he's delitting Raspberry Pis. Fuck me. One of the engineers designed Ansible, and he's doing videos of delitting a Raspberry Pi. I mean, like, so anyways, and so that's the problem, like with YouTube is if you're willing to sell towards their algorithm, you can make millions of dollars, no doubt. But again, you really have to ask yourself, is this what the hell you want to do? And so anyways, that's why I'm doing like I say with Silicon Dojo, I'd rather have 20, 30 people in these classes and actually teach 20 or 30 people than to have tens of thousands of people watch whatever the hell my opinion is about Arlington Cemetery. Truly. So anyways, that's the world. And that's where you have to think about it. Like one of the things to think about, like when I started doing classes, is remember I didn't start on YouTube, right? YouTube was such a bad system, like just bad infrastructure wise. Back in 2009, I built my own infrastructure. I had my own Xeon server sitting in a co-location facility in Baltimore City. I had it was called Flash Media Server because we're still using Flash back then. Flash Media Server. I had an Ubuntu web server. And that was the thing. Like when I originally looked at the business model Again, I wanted to charge $25 a month, and I wanted 1,000. I wanted 1,000 members. Imagine if 1,000 people watched my content, right? That was my 2009 mentality. And that's it. I'd rather have 1,000 people chucking in $25 a month, or whatever, whatever, getting paid, than having a million, just whatever. And so again, there's a big difference. There's a big difference between RTMP, real-time media protocol, and YouTube. Right? There's a big difference between SMTP, Simple Mail Transfer Protocol, and Facebook. Right? There's the basic protocols and the basic services most of us want. And then there is the vile, disgusting mess that the oligarchs in Silicon Valley have currently created. Again, like you think about it, like with real-time media protocol, you'll never hear me complain that much about Netflix, other than the cost, and their content is crappy. They spend so much money to create really crappy content. Again, I get a little irritated about it, but you're never gonna hear me scream. You never hear me scream, Netflix, right? You want Netflix, subscribe to it. You don't want Netflix, don't subscribe to it. I don't complain about iTunes. I don't complain about Hulu. No, that's real-time media protocol. That's streaming videos. What's the difference? Right? Hulu and Netflix and Disney Plus, they're trying to sell you a product, and then they're actually trying to give you a quality product that you're going to want to come back to. Whereas YouTube and Facebook and these other things, they're trying to give you that sugar rush where you'll come back to it even when it disgusts you. Anyway, that's my opinion. So that's why I'm doing that. Again, that's why here in Asheville, again, I had the in-person thing for well over a year, about a year and a half. And I prefer doing the in-person classes. It's just Asheville is 90,000 people. We don't have a tech community. It's a very weird place that way. So that didn't work out. So again, that's why I'm doing this. And I will be doing more and more and more, more and more. Let's see here. Thanks, thank you. I learned something new today, slight variation of SQL that I know, and using it with Python with its specific syntax. Good deal. Let's see. Yes, thank you for the sesh and labs to work through. Likewise, learned something new. Very interesting. Cool. Yep, hopefully it's interesting. And again, it's all simple stuff. It's all simple stuff. I think that's one of the big things, like with a lot of professors, a lot of instructors, right? They want to feel impressive. They're like, oh, I am so cool. And so one of the things they do is they try to make this stuff seem complicated, because if they make you think it's hard and they know it, then you're impressed with them. Wow. The problem is if you convince people this is so damn hard, there's a good chance that they're going to give up, right? Oh, fuck. This is hard. I can't learn it. So again, that's why I try to break this stuff down in the simplest components, because again, what you see, HTML is dirt simple. CSS is relatively simple. Python is pretty simple. Bottle framework, relatively simple. SQL, relatively simple. If you start building on all these things, you start to realize, oh, holy hell, even I can do it. Yep. Okay, I have been yabbering. I got about 5 minutes. Does anybody have questions about the labs? Is anybody actually doing the labs? Someday I'm gonna get the technology where I can see all of your screens, and I'll be able to remote monitor whether you're actually doing something or not. I do not have that technology today, so I have no idea what you're doing. Yeah, Charles, yeah, make sure to work on the labs. Work on the labs, play with all of it. Get used to it. And then again, like I said, do the extra credit work to try to figure out how to make it look prettier, look nicer. Okay, so people are dropping off. Nobody's asking questions, nobody's leaving comments, so I think I will call it a day. So yeah, we're gonna have more classes coming up. Again, out of frame has been a complete disaster, so hopefully in the next month everything will get to be a lot more seamless. And so now we're going to start building things. So I want to start using again Bottle and SQLite and OpenAI or Olama. We're going to start doing things like actually building like AI powered web applications. So you start to understand that. And then with that, we're going to start to understand how the architecture of those systems work. Again, a lot of people talk about things like AI, and they just like act like AI is just a thing that does whatever the hell it's supposed to do. Again, AI is a piece of functionality that you wrap into a much larger system to actually provide whatever services that you want. So since AI is the cool thing nowadays, we're probably going to do a number of classes on that. It's going to be like labs, but more complicated. So to actually show you how to build out kind of like AI type projects and also different types of projects, again, with Bottle and SQLite and those types of things. So you start to get a better idea of how to actually build solutions. So that's going to be coming this month. And yeah, we're just gonna keep trucking along. Again, I like doing this, just so you all know. Like, this is, I don't know, the 13th class we've done so far. I do like doing this, so I'm gonna keep doing this. Donor box exists. Just saying. Um, Hopefully some more people will throw some money in a donor box and we can make this a successful thing. So yeah, so we're just gonna keep plugging along. Again, we're basically gonna focus just on the Python world. Again, when I started thinking about Silicon Dojo a couple years ago, I thought we were gonna do a lot of different stuff. But I think Python's like just focusing on Python is a better idea because there are so many things that you can do with Python. And then if you decide that JavaScript is a better way to go, there's 1,000 people out there that can teach you JavaScript. So yeah, we're just going to focus, like I say, on this Python world and just keep building. And yeah, that's all I got to say. So see you all. Again, this class will be up on the Eli the Computer Guy channel, probably in a day or so, if you want to go over and watch it again. That's all I got to say. See y'all later.